calculus isn't really the calculus, it's just remembering algebra, like how things simplify. So I just wanted to start off this whole first unit. We're not really doing the chapter 1 out of the book. I've kind of put together my own list of things that I feel like we really need to know moving forward. So the first thing I just want to touch on is kind of reviewing factoring a little bit. So x squared minus 25, how do we factor that? Difference of squares. So remember, these are two perfect squares. If there's a subtraction, it factors into 2 parentheses. The only difference is one's plus and one's minus. And in factoring, does order matter? Okay. But number 2, if I make it addition, can we factor it? No. And if we can't factor something, we call it Right, number 3. How would I factor this? So 16x squared would break into a 4x. One's plus and one's minus. And what multiplies to 1? Alright. In factoring, we always check for a greatest common factor first. And if that doesn't work, then we look for difference of squares, trinomials, those kinds of things. So when you're factoring trinomials, we want it to multiply to, so 2 numbers that multiply to a positive 10 and add to a negative 7. Number 5. How did you factor this one?
It goes into x squared minus 9x squared plus 9.
Okay. Okay, so difference of squares. But we always have to make sure it's factored completely. So when we look, x squared minus 9 is still a difference of squares. So that would break into x plus 3, x minus 3. And then x squared plus 9, can that go any further? No. Okay. Looking at this one, what could we do? Greatest common factor. Now when we, what do we do with that 3? Take out the 3. So then we have our 2 parentheses. So x squared breaks into x. What multiplies to positive 8 and adds to negative 2? Nothing. Is it? So is it prime? No, because we took out the 3, but we can't go any further. So this is our final answer. Sorry, I made you guys all erase from my head. Do we have a greatest common factor? Okay. How did we factor this then? So kind of depending on, some of you have different methods, some of you learned box method. Was anyone in here, anyone learned slip and slide? Okay. So we kind of have both ways. You guys just have to tell me, so which way you want to, what did we do with slip and slide? Was it like, no, never mind. That was a different method. So if you do box method, you set up like this. If you do slip and slide, you do it like that. So either way, if you do box, you're looking for 2 things that multiply to 6 and add to 5, which would be so then you get 2x plus 3 and x plus 1. If you did slip and slide, so you bring your 2 over, so then this would factor in 2, x plus 2, x plus 3, but then what do you have to do? So that gives you an x plus 1. This doesn't reduce, so the 2 goes in front, so 2x plus 3. Alright, I'm okay with whichever way, and it seems like we're kind of split in here, which way you guys, some of you learned it different ways. So, does everybody understand one of those two ways? Box or slip and slide? Number 8. So again, you could do box method. If you did slip and slide, so the 12 comes down. Multiply negative 12 and add the positive 1. And then what would you do? Okay, so that reduces to a 1/3, so that would be 3x plus 1. This is 1/4, so 4x minus 1, which should be the same thing you got with box method. Number 9. So either method. I did the last one slip and slide, so I'll do box method this time. So multiply to negative 6, add to positive 5, so that would be a positive 6 and negative 1. Factors, so you get 3x minus 1, x plus 2. Looks good? Alright, and number 10. No greatest common factor. What multiplies to 4 and adds to 3? Nothing. So we just call it prime. Alright. Is that one okay? So then I put some ugly problems on here, just because that's fun, right? So let's do some of these together. Let's do, I don't know, 11 or 12. Which one do you want me to do? 11? Okay, so sometimes we're going to come up with some really nasty answers that we might want to simplify so it's not quite so nasty. Now, we're probably not going to get answers like this until January, but it never hurts to go ahead and just start talking about what could I do to clean this up. Options, could you sit and multiply all this out if you wanted to? Yeah, absolutely. That's correct. Nothing wrong with it, but it takes some time, doesn't it? So we're just seeing, like, what are some things I could do? What else do you guys notice about this? We're trying, our directions were just to factor it. How many terms do we have? 2. Terms are separated by addition and subtraction. This whole thing is a single term. And this whole thing is a single term. Right, so we are looking for a greatest common factor. The first term has a 5. Does the second term? No. So I can't pull that out. This one has a 2x plus 1. Does the second term? Yes. So they both have this in common. Now when you do greatest common factor, you always take out the smaller of the exponents. So this one's a 2 and this one's a 1. So what am I taking out? Let's see what we're left with. So in the first term, I still have the 5. We had 2 of these, but I only took out one of them, so it has a 2x plus 1. Second term We still have the 5x minus 6. I took out that, so it has a times 2 and another times 2. Have I lost anybody? Could we leave our answer like that? Technically, yes. I just said to factor it. Could we clean it up? Yeah, it really wouldn't be too hard now, would it? If we... So if I distribute this 5 times 2x is 10x plus 5. Over here, 2 times 2 is 4. Can I just distribute the 4 then? So 4 times 5x is 20x. 4 times 6 is 24. So 10x plus 20x is 30x. Positive 5 and negative 24 is negative 19. Did you have to go that far? Not necessarily. That's one thing I told you guys yesterday, like, we'll reach a point here where I will probably be collecting and grading all of your homework just because we'll have things that there's so many possible stopping points. Okay, and it's okay, unless I specifically say to multiply this all out and simplify fully, it would have been okay to stop sooner. All right, I just want you to get familiar with various forms of leaving your answer. Any questions on that one? Let's try another. Okay, again, kind of ugly. Do you guys want to try for a second on your own, or do you want me to work through it with you? Take a second and see if you can figure out what to take out at least before we go through that part. How many terms do we have? 2. I didn't want to do that. Here's a term. Here's a term. Okay, so the first thing, this one has a 4. Does that one? Okay. What about these coefficients? Here are those numbers. Could we take out a 2? Okay, it's written funny because I put the 2 back here instead of in front, but it's still a greatest common factor. This one, do they both have the x plus 5? Yes, so we take out the smaller exponent, so it would be x plus 5 to the 3rd. What else do they both have? Okay, this has 2, and this only has 1, so we can only take it out to the 1st. Alright, so let's figure out what's left. 4 divided by 2 is 2. I took out all 3 of these, and I took out one of those, so it's a 2 times x minus 1. Minus, I took out this 2. I took out 3 of these, so I'm left with an x plus 5. And I took out that. You guys agree with me here? Could I do anything else to clean it up? Probably. Let's see. So we have a 2, x plus 5 cubed, x minus 1. All right. In here, if I distribute this one, I just take the negative through. 2x minus x is x. Negative 2 minus 5 is negative 7. Lots of fancy algebra, right? Questions? Let's try another one together. How many terms? 2 terms. Start with our coefficients. The first one has a 2. The second one is written in the middle, but it's just a 3. So can I pull out any plain numbers? No. Next thing. Do they both have an x plus 3? Okay, so we can take out an x plus 3. Now, I threw a curveball at you here, so I put negative exponents. And I always tell you, you take out the smaller exponent. So what is smaller? Negative 2 or negative 1? Negative 2 is smaller. Right. They both have an x minus 2. So what's smaller? The cube or the square? Everybody understand where I got the things I'm pulling out? Let's see what we're left with. So we had a 2, we didn't pull it out, so that stays. X plus 3 to the negative 2, I took all of that term out, so it's gone. X minus 2, I took out 2 of the 3, so there's one of them left. How do I figure out the new exponent? I had a cube and I took out a square. How do I know that this is? You subtract them. Okay. So in this term, would you guys care if I put the 3 in front here? So the x plus 3. You just said that when you're factoring out, you're subtracting those exponents, right? So what's negative 1 minus negative 2? Positive 1. So it's just an x plus 3. You guys all see where I got that? And then the x minus 2 squared, we took out all of that. So we could go ahead and distribute in here. Did you guys get 5x plus 5 for that parenthesis? Okay. What else, just as a side note, what does a negative exponent mean? Negative, yeah, would move to the bottom. So you could write the x plus 3 squared on the bottom. You guys know what I mean by that? You could write it as a fraction. So either way, I'm not going to care, but I just want you to understand there's a lot of different ways you might write your final answer there. Questions? Are we getting better with the nasty factoring? You want to try the next one on your own, or you want me to do it with you? Try it? Okay. There are a couple possibilities for what you might have done on this. So again, both of these we are looking at two terms. Some people I noticed did go ahead and take out a 1/3. If you did that, what would the 4 become? 12. When you factor something out, you're dividing, so it's like 4 divided by 1/3, or 4 times 3. But if you didn't take out the 1/3, it's not wrong either. So again, a couple ways you might have your answer written. So I think everybody took out the 2x minus 5. And you can just take out a first, and then an x plus 1 to the, okay, and I'll try to show you both ways your answer might be written here. So if you didn't take out the 1/3, you have a 2x minus 5, and that's it. In that term, this one, you have a 4, you took this out. For this exponent, it'd be 1/3 minus negative 2/3. So 1/3 plus 2/3 is 1. Okay, so if you did this, you have some more fractions to deal with along the way. So 2/3 minus 4. So 2 over 3. 4 is like 12 over 3. So what do you get? 2 minus 12 is negative 10 over 3. Practicing our mental math here. Common denominators. You have a negative 5/3 minus 4. So 4 would be 12 over 3. So that would be a negative 17 over 3. So you might have it written like this. You might have taken out a 1/3. Okay, so you don't have to have both of these. In which case you would have wound up with a negative 10x minus 17 here. You could have taken out the negative and had 10x plus 17. You could have moved the negative exponent down to the bottom, so lots of different things. Does anyone need me to look at theirs and see if they're correct? One more. All right, so number-wise, you could even go ahead, this has a 2 and a 3, so that's like a 6. This one has a 1/2, so you could take out a 1/2 if you chose to. You didn't have to. Either way, you'll get to the answer. But we definitely have to take out a 3x plus 1 squared and an x minus 3 to the what power? Negative 1/2. I'm going to go ahead and take out the 1/2 this time. I'll plot fraction just because I did the other one the other way, but you didn't have to do it like this. So 2 times 3, that's 6. If I take out the 1/2, that means 6 divided by 1/2. To divide by fractions, you flip and multiply. So that's 6 times 2, so you would get 12. We took out this. Right, this was 1/2 minus negative 1/2. So you just get 1. This term you took out the 1/2, you took out 2 of the 3x plus 1, so we just have 1 left. And we took out all of this. So taking out that fraction really actually makes our problem a lot prettier to deal with. you get something like this. If you wanted to, is there something else we could pull out at this point? Does anyone catch it? Yeah, you could take a 5 out of that last parenthesis. Again, just a matter of where you stop in your simplifying. Yes. Okay. So far, so good? All right. I have a couple minutes left, so can I use them?
Yes.
All right. Last thing I wanted to review, rationalizing. What does it mean if I tell you to rationalize? Get the Yeah, I don't want a radical on the bottom. How do I move that? So I just multiply by the square root of x plus 3 on top and bottom. So on the top, what do we get? 4 square root of x plus 3. On the bottom, what happens when you multiply those radicals? Yep. The square root drops and you just have the x plus 3. All right. 17. What do we do? Same thing. You multiply by the square root of 7 minus x on top and bottom. You want to be careful how you write that. This x minus 1, that's 2 terms, so I'm just going to put it in parentheses and then the square root of 7 minus x. You could distribute also if you chose to. And the bottom is just 7 minus x. So I'm just trying to show you, in calculus, you need to get away from the idea that all your answers are nice and pretty. You can have ugly things. Okay? Doesn't mean you did anything wrong. All right, what if we have 2 terms? Not close. Conjugate. You multiply by the same thing, but you change the sign. And then we have to FOIL. So we're going to multiply by the square root of 3 plus the square root of 2 on top and bottom. So the square root of 2 times the square root of 3 is the square root of 6 plus square root of 2 times the square root of 2, square root of 4, which is 2. On the bottom, when you FOIL, you get 3 plus radical 6 and minus radical 6. So if you don't even write those, it's okay. That's why we do conjugates. Minus 2. So on the bottom, 3 minus 2 is just 1. Or you can say it's square root of 6 plus 6. Next one. What do we multiply by? So we're FOIL. The square root of 3 times 2 radical 3. So that would become 2 square root of 9. What's the square root of 9? 3. So 2 times 3 is 6. Minus 3 radical 3 minus 2 radical 3 plus 3. On the bottom, we know because they're conjugates, all we really have to do is first and last. So this would give me 4 radical 9, which becomes 12 3 is 9 minus 5 radical 3 over 3. Can I reduce that at all? In order to be able to simplify, we have to be able to reduce the numbers outside the radicals. 5 isn't divisible by 3, so that's our final answer. Alright, I know we've got a couple more. Those are just more practice multiplying with the conjugate. Are there any questions on these? Okay.
15.
Yes.
I missed this stuff with the
Okay. Alright, so tomorrow